This is Mr. Gillum, and today we're going to continue to graph quadratic functions in standard form. So another graphing day, okay? And when you're graphing any quadratic function, and when I say quadratic, I'm talking about anything with an x squared in it, okay? Where x squared is the highest power, 2 is the highest power, okay? The a value does something special when it's in this form. Y equals ax squared plus bx plus c. In fact, each of the a, b, and c each do something special, okay? They determine parts of our graph. The graph will hold water if a is positive, and it will spill water if a is 0. So for example, if a is any positive number, it'll hold water to where both of these are pointing up, because if I put water in here, it would hold it like a bowl. However, if the a value is negative, what's going to happen is it's going to spill water. And so instead, it'll be a parabola that's upside down. The quadratic will look like this, where the water would spill out everywhere. Okay? And so the a value, the number in front of the x squared, can tell you all the stuff just by looking at the given function. Okay? If a is bigger than 1 or less than -1, that means if a is a number, an integer, bigger than 1, okay, it'll become more narrow. So if a is a number like 2 or 3 or -2 or -3, it will get narrower and narrower the bigger the number gets. Okay. However, if it's a fraction like 1/2 or 1/3 that's in between 0 and 1, positive or negative, it'll get wider. So if it's 1/2, it will get wider. If it's 1/4, it'll get even wider, and so on. Okay. So if this number is a fraction, you're going to have a fat parabola, okay, or a fat quadratic, okay? And that's what the a value can tell us. Also, it's used to help find the x-coordinate of the vertex with the b value, okay? So the b value, the number right in front of the x in your standard form function, helps us to find the x-coordinate of the vertex. Now, this is the key for today, okay? This is the most important part, okay? Because on any quadratic, any x squared function, you can always find the x-coordinate of the vertex by taking -b over 2a, or the opposite of b over 2a. Okay, so to find the x-coordinate of the vertex, this is the most important part of the day, the opposite of b over 2a. So if b is positive, you take it, it's a negative. If b is negative, you make it a positive. All right. Finally, the c value, this value out here, that's actually the y-intercept. So that gives you another point on your parabola. Okay? This value is the y-intercept of the graph, just like y equals mx plus b. Okay? And so what we're going to do today is we're going to try to graph quickly. Okay? We're going to make this much simpler than using a t-chart. The vertex is either the minimum or the maximum value of a parabola. Okay, that means it is either the tip top or the very lowest point. All right, the x-coordinates of the vertex also determines where the axis of symmetry lies. Now, these are two new things for us, min and max and axis of symmetry, and we're going to talk about those more in a second here, but all this stuff revolves around the vertex. Okay, the vertex is the key point to any parabola or any quadratic. Okay, the maximum minimum values. The vertex, that point, will actually be the max or the min. As you can see, if I have a parabola here, the lowest point is the vertex, therefore it would be a minimum. If my parabola is opening downward, the highest point on my graph will be the vertex, so it would be the maximum. All right, so the min and the max are found very easily. They are literally they are the vertex, and you will either have a min or a max. You will never have both. And finally, the axis of symmetry. Now, this can be a little confusing. I just want to remind you, if you have a coordinate plane here, okay, and I say graph the line x equals 1, that is a vertical line through 1. And I can draw a parabola around that to where it's symmetric. And looky there, it actually goes through the vertex. Okay, so the opposite of b over 2a, the x-coordinate of the vertex, is actually the line, or the axis of symmetry. X equals -2. If that's my axis of symmetry, no matter what my parabola is, whether it opens up or down, I know the axis of symmetry is right there. It might open up or down or wherever, but opposite of b over 2a tells me that is the equation of the axis of symmetry. Okay? Opposite of b over 2a. That is the key for today. All right, so today what I want to do is I want to graph quadratic in the form, standard form, y equals a x squared plus bx plus c. And this is how I'm going to do it. Okay, I'm first going to find the x-coordinate of the vertex by taking the opposite of b over 2a. I'm going to plug that number, whatever it is, into my equation to find the y-coordinate of the vertex. I'm going to graph my y-intercept, which is given to me as the c value. And I'm going to draw my axis of symmetry, which is literally the line x equals the opposite of b over 2a. Whatever that number was, that's the axis of symmetry. It goes right through the vertex. Okay, I'm going to plot the point on the opposite of my axis of symmetry across from my y-intercept. I'm going to connect my dots to form a parabola. And so let's do a few here. Check it out. Let's just get familiar with a, b, and c. Okay, and we'll get more familiar as time goes by. But a is always the number in front of x squared, and b is always in front of x, and c is always the last number. So a in this case, because there's no number in front of x squared, is 1, because anything times 1 is itself. So really this is 1x squared. B is negative 2, and c is negative 1. All right, and so I'm going to begin by graphing my parabola. I'm going to take the opposite of b over 2a. And so since I've already labeled what a, b, and c do, okay, let's just talk about what a, b, and c do. A is positive, so it should open up. B will help me find my x-intercept, sorry, my my x-coordinate of my vertex, and c is literally the y-intercept. Okay, so I know all this before I even graph. I know what it should look like. Okay, so let's take a look here. I'm going to take, for the x-coordinate of the vertex, that's what I'm doing right now. Okay, I know it's the opposite of b over 2a. And so I'm going to take my b, since it's negative 2, I'm going to say negative 2 over 2 times a, 2 times 1, which is really 2 over 2, which is 1. Now, this is my x-coordinate of my vertex. So if I have my vertex point labeled, 1 will be my x-coordinate. I still need my y-coordinate. Because I have my x-coordinate, what I can do is I can plug it in the equation and solve for y. So let's do that. I have y must equal x squared minus 2x minus 1. And instead of x, I'm going to go ahead and put in 1 because I need to know what y-coordinate goes with x when x is 1. Y must equal 1 minus 2 minus 1, which is negative 2. Y equals negative 2. So I'm going to say that my vertex is at 1, negative 2. Okay, this is so important. I'm going to come over to my graph here, and remember this is the x-axis and the y-axis. I'm going to label my vertex at 1, negative 2. It's going to be that point right there where I just plotted it. Okay, and the next thing I'm going to do is I'm going to go ahead and graph my y-intercept. Now remember, the y-axis is the vertical axis, and the c value, what we already found in the beginning, is the point on the y-intercept. So because my c value is negative 1, I'm going to go ahead and put negative 1 there on my y-intercept. Then I'm going to draw my axis of symmetry. And the equation of the line for my axis of symmetry is x equals 1, because the opposite of 2b, we decided, the opposite of b over 2a was 1. That's my vertical line, and it should always go through the vertex. So I'm going to go ahead and draw axis of symmetry on here as a dotted line because it's not actually solutions to the graph. I'm going to label it AS for axis of symmetry. It should go right through the vertex, and it's kind of like a reference line is what it is. And because I know parabolas reflect across the axis of symmetry, I have a point on this left side where my y-intercept was. I'm going to reflect it to the other side as well. And as you can see, without any t-chart or any plug and chug kind of stuff, okay, I can actually form a parabola right now. Okay, and please be sure that it is nice and curved at the bottom and you're continuous. It's holding water just like my A value said. Okay, and so we have a pretty good looking graph without a whole lot of work. All right, so one more time, I went opposite of b over 2a. found my x-coordinate of my vertex, which is also my axis of symmetry. That was 1. Then I plugged it in to find my y-coordinate of my vertex. Okay, I got -2. I plotted my point, plotted my y-intercept, which is the c value, made my axis of symmetry, and reflected that intercept across the other side for my third point. Okay, so let's just do another one here. Okay, once again, let's label A, B, and C just so there's no confusion. A is the one in front of x squared, B is in front of x, and C is the final number. All right, and so like my last one, okay, I'm going to start with the opposite of B over 2A, and that's going to tell me both the x-coordinate of my vertex and the axis of symmetry. So this is the x-coordinate of vertex first and foremost. So let's just get it going here. Let's make our vertex right up here. All right, and I know it's the opposite of B over 2A. It's something you need to memorize. -6 over 2 times 2. Okay, so the x-coordinate of my vertex is actually -6 over 4, which is -3/2. So I'm going to go ahead and put that in here for my x-coordinate of my vertex, and I know it's also my axis of symmetry. Okay, so I can even label that right now so I don't forget. My axis of symmetry, that should be a colon, is x equals -3/2. Okay, and so I go on, I need my actual vertex, I still am missing my y-coordinate of my vertex. So I'm going to plug -3/2 into my equation. Y equals 2 times -3/2 squared plus 6 times -3/2 plus 3. So y equals 2 times 9/4 plus, I'm going to go ahead and cross cancel, -9 plus 3. And I'm going to cross cancel here. I have 1 and 2. So what I have is 9/2. -9 plus 3 is -6. And if I want to make 6 into halves, I know that's 12/2. So I'm going to say 9 minus 12 is 3. -3 to be exact, -3/2. All right, so I know my y-coordinate of my vertex. When x is -3/2, y is -3/2. And so that's what first point I'm going to plot. -3/2, -3/2. Right there in the middle of that line. Okay, now I'm going to draw my axis of symmetry. X equals -3/2. Right through the middle there, it's a dot. I'm going to label it A dot S. And, oh, I think I forgot to label the maximum or the minimum on the last one. Okay, you need to go back and do that in your notes. Okay, but we're going to move on. I also know what the y-intercept is. It's actually my c value, whatever is given to me. So I'm going to put my c value down, my intercept at 3, right there. And I'm going to find another point by just reflecting across the axis of symmetry on the other side. As you can see, I have 3 points now, and I can make a parabola. Okay, and as you can see, my A, B, and C values all agree with that. A was positive, and it was a big number, so it actually got a little narrower, which it did. Okay, B helped me find my x-coordinate of my vertex as well as the axis of symmetry, and C was my y-intercept. So I have a pretty good looking graph here. The final thing I need to do, which I believe I forgot to do in the last one, okay, is label this. Is this vertex a maximum or a minimum? It holds water, and the vertex is actually the lowest point. That's really the key. It's the lowest point, therefore this is a minimum. Okay? There's a minimum value. It's the lowest value on the graph. Okay? And finally, I have a function here where it says g of x equals -x squared minus 2x minus 1. Now don't forget, g of x is another way to say y. Okay? It's just called function notation. A, B, and C don't change. What we're doing doesn't change. Okay? Everything stays the same, our same process. So once again, let's just label A, B, and C, -1, -2, and -1. And I'm going to continue by finding my x-coordinate of my vertex. -b over 2a. Okay, let's label my vertex up here. My axis of symmetry is important. All right, so let's figure this out. The opposite of b would be negative 2 over 2 times a, negative 1. 2 over negative 2 is negative 1. This is my x-coordinate of my vertex, as well as my axis of symmetry. Okay. Now I need my y-coordinate of my vertex. So I'm going to continue to take my x-coordinate. I'm going to go back to my original equation. I'm going to say, I'm going to figure out what y is when x is negative 1. So I'm going to say g of negative 1 equals negative 1 squared minus 2 times negative 1 minus 1. So g of negative 1 equals negative, now remember, order of operations. This negative does not get squared. Negative 1 does get squared. Negative 1 minus, let's do this. Negative 2 times negative 1 is positive 2 minus 1. So g of negative 1 actually equals negative 1 plus 2 minus 1, which is actually going to be 0. So g of negative 1 equals 0. Okay, now we're going to run into a little bit of, oh no, we're not, we're going to be fine. Okay, 0 would be my y-coordinate. Okay, so I got a lot going on here. I have my vertex now, my axis of symmetry, and so I should be good to go because I also have my y-intercept. That's all I need to graph my quadratic or my parabola. So I'm going to start at my vertex, negative 1, 0. I'm going to draw my axis of symmetry in at negative 1. And I'm going to dot the line because it's not actually a solution, it's more of a reference line. I'm going to label it axis of symmetry, AS. Okay. The next point I can plot, without doing any work at all, is just by looking at this negative 1 back here. It's actually the y-intercept. So I'm going to go to the y-axis, and I'm going to put my intercept at negative 1. I can also, because I know parabolas are symmetric across the axis of symmetry, I can draw another point exact opposite of the axis of symmetry. Now I can connect my dots, and I have my parabola. Okay, the last thing to do is just label the minimum or the maximum. Okay, because this would spill water, I'm going to say this is the maximum. Okay, it's also the highest point on the graph. Okay, the graph never goes above this point, so my vertex is actually a maximum this time.